Okay, let's look at question 7. Many crops. Okay, question 7 is from year 2004, paper 1, question 9. Many crops will not grow well in an acidic soil. Which type of chemical reaction takes place when farmers add calcium hydroxide to the soil? Now, if you recall, calcium hydroxide is a group 2 hydroxide, so this is actually an alkali. Calcium hydroxide is an alkali. So if you add calcium hydroxide, that means when you add an alkali to acidic soil, so alkali and acid, acid alkali, that is called neutralization reaction. Okay, then after that, question 8 is from the salt chapter. It's from 2005, paper 1, question 9. Aqueous potassium sulfate can be prepared by titrating dilute sulfuric acid against aqueous potassium carbonate. Which conclusion can be drawn from this information? Titrating sodium dilute sulfuric acid against potassium carbonate. So this reaction is actually H2SO4 sulfuric acid, potassium carbonate. Okay, and then after that, of course, you get potassium sulfate, and this is a carbonate and an acid. So if you recall, carbonate and acid and carbonate, you get salt, water, and carbon dioxide. So salt, water, and carbon dioxide. So which conclusion can be drawn from this information? Potassium carbonate is insoluble in water. Anyway, you know that all carbonate is soluble in water. No, all carbonate is not soluble in water except group 1 and group 2 carbonate. Okay, again, this is from the solubility table. All carbonates not soluble except group 1 carbonate and ammonium carbonate. So the first one is obviously wrong. Potassium carbonate neutralizes sulfuric acid. Potassium carbonate neutralizes sulfuric acid because carbonate and sulfuric acid, you get sulfate, and this sulfate salt is neutral. So when carbonate add to when potassium carbonate is added to sulfuric acid, you get something which is neutral, and of course what happened is your carbonate neutralizes acid. So this is correct. Carbonate and acid, you get something neutral, so that is called neutralization. Potassium sulfate is a base, cannot be. Potassium sulfate is insoluble in water. All sulfate is soluble in water from your solubility table. All sulfate soluble in water except these three, and potassium sulfate is not any one of these three. So this is wrong. So the answer is B. Let's look at the next question, year 2006, paper 1, question 9. The pH values of 4 aqueous solutions are shown. Which solution contains a weak acid? Okay, so just have to remember the range of the pH values. This is a strong acid. This is a weak acid. Of course, this is neutral. Okay, so this one is just the pH scale. Okay, the next question is a question from the salt chapter. This is year 2007, paper 1, question 9. Salts are made by reacting acids with bases. For which acid-base reaction is the titration method used? So in order to use acid-base reaction to make salt, which of the following statement is true. So if you recall from the salt preparation, okay, in order to prepare salt using titration method, the starting materials must be soluble. Okay, in order to use this titration method to prepare salt, the starting materials must be soluble. So in this case, your acid must be soluble, your base must be soluble. Okay, as a soluble acid and a soluble base. Both must be soluble. Question 11. This is from year 2008, paper 1, question 10. Distilled water contains dissolved carbon dioxide. What is the pH value of this distilled water? Now, for this question, you need to be aware that when carbon dioxide dissolves in water, it would form carbonic acid, which is a weak acid. Okay, it's from here. Carbon dioxide dissolve in water, you will get carbonic acid, and this is actually a very weak acid. So the pH value of this distilled water which contains carbon dioxide, that must be weak acid. So pH 5, because this is neutral, this is alkali, this is strong alkali. This is weak alkali, strong alkali. Weak acid is here. Okay, the next question is from year 2008, paper 1, question 11. Magnesium sulfate cannot be prepared in the laboratory by the reaction of dilute sulfuric acid with what? Now, dilute sulfuric acid with magnesium. Magnesium is a reactive metal. Reactive metal and acid, you get salt and hydrogen, and the name of the salt is magnesium sulfate. How do you know? You just write down the equation plus magnesium, you will get MgSO4 plus H2. So this is magnesium sulfate. Magnesium sulfate. How about magnesium carbonate? Okay, plus magnesium carbonate, you get magnesium sulfate. So same thing, plus the rest of the product is not important, because all you need to make sure is magnesium sulfate can be obtained from this reaction. The next one, magnesium chloride and acid. Now there is, if you recall from the reactions involving acid, there is no reactions here that involve acid and chloride. You only have acid and oxide, acid and hydroxide, acid and carbonate, acid and reactive metal. There is no reaction between acid and chloride. So this one, magnesium chloride and dilute sulfuric acid, you don't get anything. How about magnesium oxide? Yes, oxide and acid, base and acid, or alkali and acid, you get salt and water. So H2SO4 plus MgO, you get MgSO4 plus water. Okay, so the answer is C, cannot be prepared. Question 13. This is from year 2009, paper 1, question 11. Which substance is used to decrease the acidity in a soil? When the soil is acidic, you need to add alkali to neutralize it. So which one of this is alkali? An alkali, group 2 hydroxide. So that would be B. So basically alkali is a soluble base, which is group 1 or group 2 base, and calcium is group 2 base. So calcium hydroxide can be added to neutralize the acidity in a soil. So the answer is B.